5 patterns, 10 seconds each, one code smell hiding in every round. Watch this. A class takes an object in its constructor, calls one method on it and gets a completely different result depending on what you handed it. No if statements, no case list, just different behavior. What is actually going on here? By the end of this video, you will spot patterns like this in seconds, not minutes. Hey, I'm Kai and this is Fun with Learning Technology, the place where I break down how things actually work instead of just telling you the steps. Here's the game, 5 rounds. Each one drops a piece of code with a design pattern hiding inside it. And you guess before I reveal. You don't need to have memorized a textbook full of patterns for this. Most of them give themselves away with one honest clue, if you know where to look. That's the real skill we're building today. Reading the clue, not memorizing the name. Most people write this as one big if-elif chain. If it's a credit card, do this. If it's PayPal, do that. And every time the business adds a payment method, you crack this class open again. This processor doesn't work that way. It doesn't know or care whether it's paying by credit card or PayPal. It just holds an object and calls one method on it. Swap in a different object at the start and the entire behavior changes with zero edits to the processor. What pattern is that? Take your best guess before I flip to the processor. What pattern is that? That's the strategy pattern. Think of a universal charger. The socket in the wall never changes. You just plug in a different adapter for whatever device you brought. Same socket, different behavior. The code clue was that the algorithm, how to pay, got handed to the object from the outside as another object instead of being written as a branch inside the class. Anytime you see a class taking in a small interchangeable object and just calling one method on it, that's strategy talking. That's strategy talking. That's 1 down, 4 to go. New round, new smell. This feed keeps a list of subscribers, and the moment a story gets published, it loops through every single one and tells them. Nobody asked the feed to run one specific algorithm, it's just broadcasting to a crowd. Same idea as round 1 or something different. Guess before the reveal. That's observer. In round 1, we swapped in exactly one object to change behavior. Here, the feed is talking to a whole list of listeners at once, and it doesn't know or care what any of them actually are, only that they can be updated. That contrast is the real tell. Strategy is one object standing in for an algorithm. Observer is one object shouting to many. Here's the trap round. An order holds a status object and calling next hands control to that status object, which decides what the new status should be. That sure looks like round 1, an object doing the work through another object. But watch closely. Who is choosing the replacement object here? Take a guess before I show you the flip. This one's state, not strategy. In round 1, the caller decided which strategy object to plug in. Here, the order never gets handed a new status from outside. The current status object decides its own successor and swaps itself out. Same shape, opposite direction of control, and that's the whole ball game. I'll be honest, I mixed these two up for months early on, because on the page they look almost identical. The fix that finally stuck, ask who picks the replacement, the caller, or the object itself. This round is less about one code block and more about what happens when it actually runs. A plain coffee object gets wrapped by a milk object, that gets wrapped by a sugar object, and that gets wrapped by a whip object. Every wrapper adds its own cost, then passes the call down to the one it's wrapping. Here's a real question for you. What do you think the total cost looks like if you ask the outermost wrapper for its price? Drop your guess in the comments before the next slide shows the runtime chain. Decorator. Milk wraps coffee, sugar wraps milk, whip wraps sugar. Each one holds a reference to the object just inside it, and every call cascades all the way down and back up, picking up a little extra behavior at each layer. The clue here isn't in one line of code, it's in the shape of the relationship, objects wrapping objects, all pretending to be the same thing from the outside. Last round, and it's a messy one on purpose. This class wraps a real repository, same as round 4's wrapping trick. But look at what it's actually doing. It's not stacking new behavior on top, it's standing in front of the real object and deciding whether that object even needs to be bothered. Same shape as Decorator, different intent. What would you call this one? This one's Proxy, specifically a caching proxy. It wraps the real object the same way Decorator does, but the intent is different. It's controlling access, deciding when the real object even gets touched, not adding new behavior to it. Here's my honest take. In a real code base, whether you call this a proxy or a decorator matters a lot less than whether your team agrees on what it does. The structure genuinely overlaps. That's not a trick question. That's just how these two patterns actually are. Let's tally it up. Strategy is handed to you from outside. Observer is one object broadcasting to a crowd. State replaces itself from the inside. Decorator wraps to stack on new behavior. And proxy wraps to control access to what's already there. Score yourself honestly. How many did you actually catch before the reveal? So back to the question we opened with, how do you actually spot a pattern instead of guessing? You look at who's really in control, who hands in the behavior, who's broadcasting, who's replacing itself, who's just wrapping. That one question will get you further than memorizing 23 pattern names ever will. Next time code smells like this, ask it before you reach for a name. Tell me in the comments which round tricked you.